Today's lesson, we are going to look at the graphical user interface and the command line interface, or the GUI versus the CLI. Most computer users are very familiar with the graphical user interface, especially since most of us have grown up using either Microsoft Windows or Apple Mac OS. And this is the normal way that we interact with and learned how to interact with our computers. However, there are other ways of interacting with and getting your computer to do things. The command line interface and the graphical user interface are both ways that we can engage with and interact with a computer and get it to do certain tasks for us. But it is how we input these tasks and receive output from these tasks that differentiates them. The command line interface needs the end user to type out the commands and instructions on a terminal, while the graphical user interface requires the end user to simply visually select tasks and click or touch them. In this lesson, we are going to look at both of these interfaces. So let's start with the one we know best, the graphical user interface. It's the most intuitive and simplest method of communication between an end user and the operating system. Users can visually select what they want to do and then use touch or a mouse to trigger that action. It is ideal for casual and new users that do not mind the time it takes to visually select tasks and execute it. Shortcuts can be set to allow for faster access to frequently used programs or applications. This method of interaction is more resource intensive than using the command line interface. And this method has not always been the default way for home computers and workstations. So let's have a brief look at the history of the GUI. In 1945, a noted scientist called Vannevar Bush wrote an article for the Atlantic Monthly called As We May Think. In this article, he proposed a device that he called the Memex. This Memex was envisioned as something that today we would recognize as a smart desk, a tablet, or even a desktop PC. The Memex was described to be a storage and retrieval device using microfilm that would consist of a desk with a viewing screen, a keyboard, a selection of buttons and levers, and then the microfilm storage. The machine would augment human memory by allowing the end user to make links or associative trails between documents. Bush proposed the notion of blocks of text joined by links and introduced the terms links, linkages, trails, and even web through his descriptions of this new type of textuality. Bush's article greatly influenced the creators of what we now know as hypertext and how we use the internet today. In fact, Ted Nelson coined the term hypertext back in 1967. During World War II, the need to encrypt and decrypt messages, or even to crack enemy codes or work out artillery trajectories, pushed the calculation of machines forward. But the technology to have a true graphical user interface was not realized until much later. In 1962, a scientist called Douglas Engelbart published an essay called Augmenting the Human Intellect. In this paper, Douglas argued that digital computers could provide the quickest method to increase the capability of a man to approach a complex problem, to gain comprehension to suit his particular needs, and to derive solutions to these problems. He envisioned the computer not as a replacement for human intellect, but simply as a tool for enhancing it. One of the first examples he described for this technology was for architects designing a building, using something that today we would call CAD software. This was a huge leap in thinking for 1962. The only computers that existed at that time was giant mainframes, and typically users would interact with them using what was known as batch processing. A user would submit a program on a series of punch cards. The computer would run the program at some scheduled time, and the results would then be picked up hours or days later by the user again. The idea of having a user enter commands on a text-based terminal in real time was considered radical. Douglas and his growing following of staff worked for years to develop the ideas and technology that finally ended up in a public demonstration in front of over 1,000 computer professionals in 1968. This was a massive media event for the time. There were multiple cameras pointed at his hands, his face, and at each display. They called this system the NLS, or online system, since it was networked between various computers. The display system was based on vector graphics technology and could display both text and solid lines on the same screen. The operator's hands operated three input devices: a standard typewriter-style keyboard, a 5-key special keyboard, and a very small rectangular box about the size of a juice box with 3 buttons near the top, connected to the computer via a long wire. This, as you can now recognize, was the mouse, and it was invented by Douglas himself and built by one of his engineers. Nobody knew who first started calling it a mouse, though, but the idea for the name stuck back then, and it remained that name ever since. Mechanically, it was slightly different from a modern mouse in that 2 circular wheels connected to the internal potentiometers roll directly on the table surface instead of being manipulated by a single mouse ball rubbing against rollers. However, to the end user, it worked virtually the same way as a modern ball mouse. Many of the things demonstrated in this massive media session seem to come from the far future, and most of the people watching it couldn't even understand what they were seeing. The demonstration featured hypertext linking, full-screen document editing, context-sensitive help, network document collaboration, email, instant messaging, and even a type of video conferencing. It was all very overwhelming, and due to the limitations in the video system that recorded it, it was difficult to tell what was going on where. They were so far ahead of everybody else that nobody else could see the potential in this, and his ideas were never commercialized by his institute, and he could not find suitable investors. Remember, this was the time of punch cards, basic storage on huge tapes, and limited text input by end users. His ideas were truly from the future, and even though he never managed to commercialize it, it did inspire a certain printing company. Today we think of Xerox as a printer or paper making company, and that is where they started off. And they still do it today. But after seeing that demo from Engelbart in 1968, the Xerox upper management panicked, fearing the inevitable demise of their paper-based company in this new paperless future that they saw. So they decided that they better make sure they controlled this new technology. So they formed the Palo Alto Research Center, or PARC, in 1970. At PARC, workers were given great freedoms and support to explore and create in what they believe to be the future of computing. The first project they completed was to build a laser printer. There was, however, one issue. This printer was so advanced that it actually needed a computer with a graphical interface to use, and that didn't exist yet. So they invented it. They invented a microcomputer with a graphical user interface to drive this printer. In 1973, they unveiled the Alto. It's not a true microcomputer, and it was pretty small for its time, about the size of a mini fridge, but it did have a graphical mouse-driven user interface. And the display mapped exactly to a printed page. What you did on screen, you could print. It had a very basic user interface and rudimentary file manager. Soon there were several programs written for it, like a graphical word processing program, a graphical text editor. But this showed up a new problem. The user interface and interaction with each program was very different as different people were developing it. There was no standard to guide researchers and scientists. The Park researchers realized that what was needed was a consistent user interface for new applications. And to make that happen, a whole new code base was needed. So they invented something called Smalltalk. Smalltalk was conceived as a programming language and development environment to easily use. In fact, it was described to be so easy that even a child could understand it. And in many aspects, it was successful in this goal. Smalltalk was the world's first object-oriented programming language, where program code and data could be encapsulated into single units called objects that could then be reused by other programs without having to know the details of the object's implementation. It also had modern Java-like features like automatic memory management to take some of the hard work away from the programmer. The development environment of Smalltalk was also the user interface that Smalltalk programs ran in, and it introduced many modern GUI concepts that we still use today, like windows with graphical borders, the ability to move and size windows, and even icons. The combination of Smalltalk and the Alto was essentially a modern personal computer with a very similar graphical user interface to the ones we use today. Altos had networking and could send email to and from other Alto computers, and it was an ideal system for the office environment. Many of the team working on this wanted Xerox to market this new system to the public, and eventually they did build a very basic model, but it was hugely expensive and it didn't really make a commercial impact. Another company, however, has seen this, and they saw the future as a GUI-driven home computer, and they were ready with their product. Apple. After the success of the Apple II computer, the Apple Computer Company under Steve Jobs had some money to burn, and this happened to coincide with the end of many contracts for researchers at Xerox PARC. So Apple started to hire up some of the brightest minds in the industry to work on their new Lisa computer. It was initially meant to be a traditional microcomputer with a text-based command line interface, but after one of the engineers took Jobs around the Park campus and showed him the Alto and Smalltalk interface, he was sold on the concept of a graphical user interface instead of a command line user interface. The Lisa design team decided on an icon-based interface where each icon indicated a document or an application, and developed the first pull-down menu bar where all menus appeared at the very top line of the screen. The Lisa team also included the idea of check marks appearing next to selected menu items and the concept of keyboard shortcuts for the most frequently used menu commands. The 3-button mouse from the Alto was simplified to have only one button on the Lisa. As the interface required at least 2 actions for each icon, selecting and executing, the concept of double-clicking was invented, and we still use that today. Double-clicking would become a standard way for interacting with all GUIs to launch a program, regardless of the amount of buttons found on a mouse. The idea of drag and drop was also invented at this time. And the concept of having drag and drop to do file manipulation, for example, selecting a group of files with the mouse and then dragging them to a new folder to copy them, naturally developed from this concept. The Lisa was released to market in 1983 at $10,000 per unit. This high price tag and the difficulty to write code for it meant it wasn't a great commercial success. But Steve Jobs had a plan to fix that. He wanted to sell a much cheaper version of the Lisa to the public at a much lower cost. His Macintosh project achieved this goal of a low-cost graphical user interface, shipping with a small 9-inch monochrome screen, a mere 128 kilobytes of memory, no multitasking or even the ability to switch between tasks, between programs, and only a single floppy drive. This was introduced to the world in 1984, but it sold for only $2,495. Compared to $10,000, this looked like a bargain. It retained most of the GUI features of the Lisa and even shared some of the low-level code, but the operating system itself was written from scratch to fit in the small memory footprint of the Macintosh. It was a massive commercial success, so much so that several other companies now also wanted a piece of that graphical pie. One of the companies that wanted more of that graphical pie, as I said previously, was Microsoft. So in 1984, Microsoft released Windows 1.0 for all IBM-compatible personal computers. It supported color displays, and it featured most of the elements that Lisa had, but it could be installed on any PC running MS-DOS at that time. In 1987, Windows 2.0 was released, with even more features, such as the now traditional overlapping windows on the screen. After Jobs left Apple, he joined Next and immediately started work on a new operating system called Next Step. In 1988, saw the release of Next Step, the new GUI and operating system for Steve Jobs' new Next computer. It was his first major project after leaving Apple in 1985. Next Step introduced a sharp 3D beveled look to all of its GUI components. It was the first OS to use the X symbol to indicate a close window widget, and it introduced the idea of vertical menu strip in the upper left-hand corner, which could be torn off at any point so the user could leave specific menus at any point on the screen. Next Step also had a dock that lived on the side or the bottom of a screen. This was later used to build Mac OS X. The demand for a graphical user interface in Linux led to the creation of many different ones, but the most prominent two today are KDE, first released in 1996, and GNOME, first released in 1997. GNOME is the default desktop UI that ships with Ubuntu desktop, and as such is one of the most widely used Linux GUIs in the world today. If you haven't used it yet, I encourage you to install Ubuntu desktop in a VM and to play around with it, and you'll see how intuitive and easy it is and how they still maintain that same philosophy from the Xerox and early Apple days to simplify user input and make things easy to the end user to learn and understand. Okay, so we've had a look at the GUI now. So now let's take a look at the command line interface, or the CLI. This was for many years the only way end users could interact with computers. But as we saw with the GUI, it has been with us since at least 1985. But why would people still want to run things in a command line and not in a GUI? Since there are very few graphical instructions needed to run a command line interface, it makes for a very efficient and lean way to interact with the operating system. In lean, I mean it doesn't use a lot of memory or processing power. As such, it is ideal for lower spec machines or for servers where every percentage of processing power is critical. Each task and command need to be manually entered in a command line window or terminal, so it's more suited for expert users rather than casual end users. In this lesson, we will look at the two top command line interfaces you might encounter, namely Bash and PowerShell.